testing like one parameter on another and seeing how correlated they are? Is that what's going on?
So what's happening here is we want to test whether it's random. And so the way that we want to look at, well, the way that we want to do is we want to see like, are the characteristics of, first are the characteristics of the students in the small class size, in the small classrooms, in the small classes, the similar to the characteristics of the students in the large classes, and are the characteristics of the teacher the same, right? And so what we do is we put on the left-hand side of our regression a particular student characteristic. So for example, gender. And then on the right-hand side of the regression, we put an indicator variable that equals 1 if the student is in a small class, and that equals 0 if the student is not in a small class. And the coefficient on that is going to tell us how much more likely is a person to be a female if they were assigned to a small class. And if the coefficient on that regression is equal to 0, then what that's saying is that you're not more likely to be a woman. Women are not more likely to be assigned to small classes than men are. Does everyone understand that? Questions on that? Okay. So let's take this same model. So let's take this same model here, and I'm going to erase this. And so this is the test for randomization. If you regress Sij, let me call this just small. So this is equal to 1 if student I in school J is assigned to a small class. Right? And we regress that on, let's say, beta female ij, where this is equal to 1 if student I in school J is a female. And then we can put in some error term here, right? And so what this is going to tell us is this is going to tell us, we can put in a constant term. What this is going to, what this is going to tell us is, are females being systematically assigned to small classes or not, right? Because if females are being assigned to small classes, this beta here is going to be greater than 0. Right? Okay. And so when we look at the coefficients in this table here, what we see is that all of these coefficients are statistically insignificant, and they're pretty small. And so what this is suggesting to us is if we look at the difference in the observable characteristics for students, they're not different between the small classes versus the large classes. Okay. Now, when we look at table 2, what is table 2 reporting?
It's reporting the effect that small classes has on each of these particular groups of students, controlling for grades, like what year in school they are.
Right. Sorry, I have one correction. I apologize. I flipped these two. I saw a lot of confused things. I think that's why that was that. So this should have been the characteristic female. Sorry, ij is data small. My apologies for this. So is a female more likely to be in a small school than in a small classroom versus a large classroom, right? And so you can think about this. This outcome is the assignment variable for females, right? If I'm a female, am I more likely to be in a small classroom versus not being in a small classroom? I still see confused looks.
I don't know, I'm just having a hard time understanding what that means.
So, why is there not an error term?
No, an error term, we can put an error term in there as well too. They have an identity like VIJ. But this is, the coefficient of interest is going to be this beta. Are you more likely to be female if you were assigned to a small classroom or not? Say that again.
Why? I don't get why they're scared.
So whenever you, okay.
But
So,
like, what? Okay.
yeah, so,
Like, I.
yeah, okay. So the null hypothesis here would be, for this particular regression, would be, okay, women are more likely to be assigned to a smaller classroom, right? And so then what we want to say is, what's the, so under that assumption, what would happen is, if that's in fact the case, then like if I'm a woman, I'm more likely to be assigned to a classroom if it's going to be smaller, but there may be some other unobservable factors too that might be affecting this. Now, because we have a random experiment, then that should actually take care of that. And what we should see is that there's no relationship between the gender composition of the class and whether the class is small or not. So that's the key idea. Okay. So in table 2, what we look at then is, what is the effect of class size on student outcomes? And so that's effectively running this regression here, where we have this Sij is going to be an indicator for whether the class size is small or not. And then in the first column, what we do is we run that regression on just the students that are in kindergarten in our class. And so when we look at this, what's the coefficient on students in kindergarten from column 1? 1.87. And what's the interpretation on that coefficient?
Kindergartners in smaller classes would perform better than kindergartners in larger classes.
Right? And in particular, would perform how much better?
18.7%. That would be 0.187.
0.187 standard deviations. Right? So the test score measure is then computed in terms of standard deviations. And so the outcome, so going from a large class to a small class is going to turn this indicator variable Sij into a 1. And then we have a beta on that Sij that's equal to 0.18. And so what that means is that if you're in a small class, you're on average going to do 1 standard deviation higher on the test for kindergartners. Does everybody understand that? And then in column 2 and 3 and 4, what we do is we see what these effect sizes look like for first graders, second graders, and third graders. Because this program happens for students all the way up to third grade. And we can see very similar effect sizes. So we have about 0.18 standard deviations for kindergartners, 0.19 standard deviations for first graders, and 0.14 standard deviations for second graders, and 0.15 standard deviations for third graders. And the way to think about these is in terms of t-statistics. So the number in parentheses below these coefficients are the standard errors. And if the standard errors are at least twice as small as the actual coefficient itself, then we know that it's going to be significant at the 5% level. Right? Okay. Now when we compare, so these are the overall results. So in these overall results, we group all students, male, female, black, white, free lunch, not free lunch, everybody's grouped together. In panel B, we just focus on the subsample of only black students. And what can we see in terms of the effect sizes when we focus on only black students?
There's more of an effect.
There's more of an effect. And so the effect of class size is on test performance is even stronger for black students. What about for students on free lunch?
It's not as big as the effect for black students, but it's still bigger than overall.
Right, it's comparable to what's overall. It's slightly bigger in grade 1 to 3. but we see like a positive effect for that too, right? Okay, good. Now there's some,
Why could the error be higher or that much higher for panel B?
okay.
Across the board than it is in others?
Yeah, so what are some of the differences? So in the first panel, we're looking at all students, in the second panel, we're only looking at black students. And so the number of observations is much smaller. And so the standard errors are going to be increasing because we have a smaller sample. Right? So it's more likely, yeah, that's the reason why. And the same thing with the free and reduced lunch. So we go from having the entire sample to just restricting it to like a subsample. I see a lot of faces. Are you guys doing all right? Okay. All right. Now, what are some of the caveats with this result? What were some of the problems with this experiment? Some of the challenges with the randomization of this experiment? There were a couple.
Transfer in.
Say it again.
Some people like transfer in.
Some students transferred in.
Didn't you have like certain kids like switching classes because their parents wanted them in the smaller section?
Other challenges?
Teachers with master's degrees or higher education, like having to teach larger classes. Is that one?
Yep. So when you look at the the teachers with master's degrees were systematically assigned to slightly different classes. That's almost marginally significant. So that was another issue too. And so there were a couple of challenges, right? And so what did they do to overcome this issue of, so one of the biggest threats, so students were transferring, and how did they deal with the students that were transferring in?
They randomly assigned them.
They randomly assigned them, right? And so it was like, okay, fine. So there was still a random assignment even for the students that were transferring. And there are some results where they compare just the students that were transferred. What did they do for the situation where parents moved their kids to other classes?
They kept them where they were originally assigned for.
Can you speak up, please?
They kept them in the originally assigned group because they thought that if like the family was like influencing it, it would just be better to just account for where they were originally placed.
That's exactly right. And so for the students whose parents switched, when they included the variable for which class they were in, they did not use the actual class that they ended up in, but they used the class to which they were assigned. And that's called an intent to treat effect. And so we assigned you to this particular class, but you decided to move. So it's like, well, what is the effect of assigning somebody to a small class? Some of that effect is going to come through the person actually is a complier and they stay in the small class that they were assigned to. Some of it's going to be because some of the folks that were assigned to larger classes wanted to switch into the smaller classes. And so these people, we call them defiers. And so the intent to treat effect that that is estimated in this paper is just going to say, we're going to just say, well, we intended for this person to be treated. What's the effect of assigning them to a smaller class? And so those are the results that are going to be presented here.
And the purpose of that is just a more conservative result is correct.
That's exactly right. That's exactly right. Okay. So there's one other. So when we look at table 3, who can walk us through what's happening in table 3 with the results in table 3? What are the results in table 3 capture? Okay, so table 3 is capturing the effect of small class later in their education. What's different about later in their education?
Those who were in smaller classes did better going through their education classes.
So there are two things that happen. So one is the experiment stopped after 3rd grade. And so students were no longer randomly assigned after 3rd grade. And so the question is this effect persistent? And what we do see is that we see positive gains for students who are randomly assigned to the smaller class sizes, but these gains are like much smaller than what we saw from grades 1 to grades 3. They're almost like a sixth as large. The other thing too is that these gains, in a lot of cases, are not statistically significant, even though the sign of them are positive. That if you look at the size of the standard error, so take for example the overall effect for grade 4. we have an effect size of 0.035 standard deviations, but the standard error on that is 0.025. So we don't get the traditional confidence levels, right, for that. So these effects are not significant, but they're positive. When we look, there's also another variable about whether students took the SAT score. So if you look at column 6 on page 187, and what can we tell from that? Were students who were randomly assigned to the smaller classes more likely or less likely to take the SAT? They're more likely. Yeah. And so this is an example of a.
Is this a 95% confidence interval?
So this is going to be, yes. So we have yes, it is a 95% confidence interval.
Okay.
So for example, let's look at so let's look at the effect on the probability of taking the SAT.
It's less than it's
Right? It's 0.024, and the standard error is 0.01. So this is a t-statistic of 2.4, which definitely gets us past the 95% confidence interval.
Okay.
Right? So that's going to be significant. So there's a significant effect on taking the test for college. And given that the SAT is a prerequisite for getting into college, like if you are more likely to take the SAT, then you're also going to be more likely to go to college too. And so the black-white gap in college taking is reduced considerably. All right. So I just want to stop there with this paper. This is our first time going through a paper, so if you feel a little bit overwhelmed, that's okay. We did a lot here, so what we did is we started out by motivating what's an economic model that would explain why there's a relationship between student performance and class size. So we started with this kind of very simple conceptual framework. That was notional. And then we went into seeing what is the empirical framework that we want to use. And the empirical framework is that we have some measure of student performance or some outcome that's going to be related to school inputs, family inputs, and these unobservables. We focus specifically on school size as a particular input. And what we argued is that in a lot of contexts, the class size, not school size, the class size can depend on other factors. It can depend on the student quality, it can depend on the parental inputs, and it can depend on things that we don't observe that are correlated with the things that we do observe. And that's a problem. And so what's the golden standard? If we can randomly assign class sizes, right? And so we looked at the Tennessee Star experiment in which class sizes were randomly assigned. And then we look at what's the effect of being randomly assigned to a small classroom on student performance. And then we found that during the time period of the experiment, there were very huge effects. But afterwards, those effects were still positive, but they kind of faded out. However, for the later on in life measures, we did see that there was an uptake in test taking overall, and an uptake in test taking differentially for minority students. I believe that that's in the because if you look at the effect for black students, it's twice the size of the overall effect in terms of test taking. So that's on page 186 in column 6. And also the effect of the probability of test taking is up a lot for the students who are on free and reduced lunch as well. And so there are these huge effects on student performance during the time of the experiment. There are some modest effects on student performance after the time of the experiment. And then in terms of the probability of taking the SAT, there are really important effects there. And there are differentially large effects for low-income students and for minority students too. So we've kind of closed the loop. Question? Okay, yeah. And so we're going to go through a couple more papers like this. If the first read of the paper was confusing, I encourage you to go back home and to read it through with your group. If you have any questions, feel free to email Shannon, feel free to email me with questions about that. We're going to go through more papers in terms of understanding how this type of, how you take are the methods that we learned in this class to data to like answer a research question. Let's take like a 3 or 4 minute break and then come back. And then we come back and we'll talk about our